In this lesson, we're going to look at condensing logarithms. So that's where we're going to take multiple terms with the same bases and smash them or condense them into one logarithm. We earlier looked at expanding logarithms where we had a single logarithm and then we were able to expand it out with many terms with pluses and minus signs in between. We're going the opposite direction in this lesson. So here we go with this expression, 2 log base 3 of 7 minus 5 log base 3 of x. Both have the same bases. That's good. We need to have that in order to smash this or condense this into one single logarithm. That's what we want to have here, one logarithm when we're all done. Our first step is to move the coefficients up to the exponent position. So that's the 2 here. It's really 2 times log base 3 of 7. And the 5 here, it's really 5 times log base 3 of x, with the subtraction sign between them. We looked before that we could take exponents and move them in front to the coefficient spot. Well, now we're going to go the opposite way. We're going to take the coefficients and move them back up to the exponent position. There they are. Our next step is to write a single logarithm and use a fraction bar if we see subtraction signs. If you don't see any subtraction signs, you can skip the fraction bar. Well, we do have a subtraction sign right here. So I'll write log base 3 and get a fraction bar ready to go. Then we'll fill in our fraction, paying attention to the positive and negative signs, what's being added and what's being subtracted. Positive terms, those things we're going to go into the numerator, and the negative terms into the denominator. So 7 squared, that's a positive term here, so we're going to put that in the numerator. There's a subtraction or a minus sign here before this x to the 5th, so it's going to go into the denominator. You could imagine that you could make this a plus sign, which then would force us to put a negative 1 here, and if we move the negative 1 up, it would turn this to a negative 5, which, if you put it in the numerator, would push it into the denominator anyway to make it positive. So that's how come these positive terms end up in the numerator and the negative ones end up in the denominator. And we can now simplify 7 squared. We could have done that earlier. And we get log base 3 of 49 over x to the 5th. We took those two logarithms with the same base and smashed them or condensed them into one. You can pause the video and try to condense this one, 6 log base 4 of w minus 3 log base 4 of p. And there's the answer. Log base 4 of w to the 6th over p to the 3rd. This next example is late in the process to show you that we have 4 terms here, and we play this just as we did with 2 terms. It doesn't matter how many terms we have. We're going to pay attention to what's positive and what's negative to let us know what goes into the numerator and what goes into the denominator. They all have the same base of 4. That's good. That's why we can play this game. So w squared, this is from a positive term, so it goes in the numerator. But it's a minus sign here for this x to the 7th. It goes into the denominator. Here's a positive sign for y to the 5th. It goes in the numerator. And a subtraction sign for the z. It goes into the denominator. So there is how our single logarithm gets smashed or condensed together from those 4 terms. One more example here where we have numbers and no variables. We'll see just how far we can go simplifying this. So we start with 2 log base 3 of 12 minus 4 log base 3 of 2. And our first step is to move the coefficients up to the exponent position. So this 2 is going to move up here, and this 4 is going to move up here. There they are. And this time I'm going to go ahead and simplify 12 squared and also 2 to the 4th right now. 12 squared is 144, and 2 to the 4th is 16. Our next step is to write a single logarithm with a fraction bar if we see a subtraction sign. We do have a subtraction sign here, so we're going to need log with base 3 and a fraction bar. And we'll pay attention to the positive and the negative signs to let us know what goes in the numerator and what goes into the denominator. This term is positive, so the 144 will go into the numerator. This term is negative with a minus sign, so the 16 will go into the denominator. Now let's see if we can further simplify this. 144 divided by 16, we can do that. That's 9. So now we have log base 3 of 9. And we can simplify that. Remember, the output of a logarithm is an exponent. So we're really asking ourselves 3 to what exponent power is 9? Well, it's 2. All of that condenses and simplifies down to 2.